students, welcome in electronic lecture. We have started power supply chapter, second chapter, Indian power supplies. What we have seen, basic building block of power supply, which contain, yes, first block is of transformer, second block is rectifier, third block is filter, and the last block is regulator. Isn't it? First block was transformer, second block was rectifier, third block was filter, and the last block was what? It is a regulator. So today we are going to start the regulator. Okay? Regulator. What is regulator? Its name indicates that it regulates the supply. It's called as a regulator. So why there is a need of regulator? First we see why there is a need of regulator. As we have seen in the previous lecture, why there is a need of filter. Similarly, we will see how there is a need of regulator. What happens in rectifier circuit? What happens when alternating current is converted into direct current, but some amount of AC is remain. That AC is called as a ripple. So that ripple is filtered by what? Its filter circuit. Then we get at the output as a DC supply or DC voltage. But that DC voltage or DC supply is depend, or it may be variation. It is not constant. It may be varied due to what? Due to the load current or load resistance RL. Due to the load resistance, or it may be because there is a variation in AC supply. We are using AC supply here. So see, for example, I will draw the diagram for the filter circuit. Suppose this is the rectifier we are giving here the AC supply for all filters, isn't it? This is what? AC supply, which is how much? 230 volt and 50 hertz frequency we are giving. So in rectifier, simply if you are taking the LC circuit or LC rectifier, what happens? See, we are getting here VDC, that is output voltage, and here is the RL, load resistance. This is the L and this is the C. So what we are getting in the circuit, here is a rectifier. So this rectifier, we are applying this voltage is which voltage? AC voltage. And this AC voltage is whatever we are using, MACB, whatever the supply comes from the MACB, that supply is called as the AC voltage, and that AC have the always variations. It is not constant voltage. So because of this AC also, DC will not be regulated or constant. So that is one reason. Another reason is what? Because of this load resistance RL, there is a large amount of current is flow. And therefore also, second reason is what? Because of the RL, there is a large amount of current is flowed. Therefore also we are not getting DC constant at the output. No doubt we are getting the DC in the LC circuit. In the filter circuit, no doubt we are getting 100% DC signal. But that DC signal is not constant if and if we will not use the regulator. So regulator used to give the constant DC supply. Why the regulator is used? It gives, or it is used to maintain constant voltage or regulated voltage, constant regulated voltage at the output. Therefore, there is a need of this regulator. Is that clear? Why there is a need of regulator? Okay. Why there is a need of regulator? There are two reasons. Because of this AC supply, in the AC there is a variations. So because of the fluctuations or variations, we will not get the output voltage constant. So we need the output voltage constant or regulate non-stop. Regulate means non-stop or constant voltage if you want. want to need, then you have to use the circuit is regulator circuit. Okay. Second reason is what? Because of the load resistance also, output voltage is not regulate or not constant. Therefore also we use the regulator circuit. Okay. So we'll see first, before going in detail of this regulator, we'll see the power supply. What do you mean by power supply? We'll see. Power supply. Power means what? It may be voltage, it may be current. So power contain voltage and current and frequency, all these things. Okay. So power supply mainly is of two types. That is the load regulation and second is the line regulation. Load regulation and line regulation. First we will see what is the load regulation. What characteristics, power supply characteristics we are going to see. Load regulation. These are the two properties or two characteristics, load regulation and line regulation. So what happens in load regulation? If there is a change in regulated voltage, then regulated current will pass from minimum value to maximum value. It's called as the load regulation. What is the load regulation? There is a change in regulated output voltage from when there is a change in regulated output voltage and current flow from minimum value to maximum value. It's called as the load regulation. What is this? When there is a change in output voltage, change in output regulated voltage, then current flow from minimum value to maximum value. Means what? Load regulation, that is RLR, is indicated VNL minus VFL. So what is VNL? VNL is equal to what? It is the voltage with N indicates no. Voltage with no load current. And VFL means voltage with F means full load current. Full load current. Yes, what is this? VLR is equal to, LR means what? It is the load regulation is equal to, yes, VNL minus VFL. VNL is what? It is the voltage with no load current and voltage with full load current. Suppose there is a supply given is a what? If it is VNL is 11.8, VNL is given, suppose VNL is 11.8 and VFL is 12 volt. It is given. Then how will be LR or load regulation? It is VNL minus VFL. So how much it is? 11.8 minus 12 volt, that is the 0.2 volt. Okay. So this will be what? Load regulation. So what will be percentage of load regulation? Percentage of load regulation is nothing but VNL minus VFL divided by VFL 11.2 volt, and here also what happened, VNL is how much it is, 12 minus 11.8 divided by 11.8 into 100. So this much value will be what, percentage of this load regulation. Okay, so load regulation is nothing but when there is a change in voltage, or when there is a change in regulated voltage, then current flow from its minimum value to maximum value is called as the load regulation. So this load regulation is indicated by VNL minus VFL. Okay, so VNL is nothing but the voltage with no load current, and VFL is the voltage with full load current. Suppose we have the values VNL is equal to 12 volt and VFL is equal to 11.8 volt. Then if you want to calculate the load regulation, then VNL minus VFL, which is equal to 12 minus 11.8. So how much it is? 0.2 volt. And this is the percentage of the load regulation. So what is the percentage of load regulation? VNL minus VFL divided by VFL into 100, which is equal to, given of the value of VNL is 12 volt minus 11.8 volt divided by 11.8 volt into 100 is how much? 1.69%. It is what? Percentage of load resistance, that is the LR. How much it is? 1.69%. So this is the first point of this load regulation. Now what is line regulation? Line regulation. These two are very important regulations, load regulation and line regulation. What happened in line regulation? See, line regulation is nothing but the change in voltage with its proper value. That value is what? It's given is 230 volt plus minus 10%. Plus minus 10%. Maybe there is a difference of plus 10 or there is a difference of minus 10% in the value given. So that change in voltage, that change in regulated voltage is called as the line regulation. So what is line regulation? Line regulation is nothing but there is a change in voltage or change in regulated output voltage with the difference of plus minus 10%. So it have the proper range. Their voltage should be within the range of 270 volt to 253 volt. If the range is between in these two voltage, then that voltage is called as the line regulation. Okay. So line regulation is what? It is a 230 volt plus minus 10% is the line regulation. And another name of line regulation is also called as source regulation. Is also called as source regulation, that is the SR. SR is how much it is given? SR is equal to SR divided by V normal into 100. If percentage of SR is considered, then percentage of SR is what? Which is equal to, what is, first we will see, V normal means what? Voltage or nominal voltage. Nominal voltage applied is called V norm, and SR is what? It is the source regulation or the value given to the source regulation. So this is the percentage of the source regulation. So what is source regulation? It is nothing but the range of the voltage or change in voltage within the range or within the 270 volt to 253 volt. If suppose there is a change in what? Change in voltage within the range. Suppose it's having the full voltage is 12 volt and suppose it is given its ranges. The voltage is from 9 volt, suppose 9.8 volt to 10 volt. Then what will be line regulation? Yes, what will be line regulation or SR? SR will be, yes, it is 9.10 volt minus 9.8 volt, which is equal to 0.2 volt for the SR of the load regulation. Its ranges from 9 volt, 9.8 volt to 10 volt. Okay, so it is the example. It's not fixed range. So it is the fixed range. So it is difference or there is a change in between two voltages is called as the line regulation. So this should be in the range of 270 to 253 volt. So there is a change of what plus minus 10%. This is the line regulation. All of you understand this load regulation and line regulation and why there is a need of regulation. Okay, regulation, why there is a need of regulation? Because of the constant, to maintain the constant voltage at the output. Therefore there is a need of what? Regulation. Because in rectifier circuit or in the filter circuit, what happens? In the rectifier circuit, AC is converted in DC, but some amount of ripple is remain and that ripple is removed by which circuit? Filter circuit, and that filter circuit gives as a output as a DC volt, and that DC volt is not regulated. It is in fluctuation form. It is not constant. To overcome that problem, we need the last circuit is what? Regulated circuit. Because of the regulated circuit, what happens? Fluctuation is removed and we will get the constant regulated DC supply. Regulated means non-stop. Constant and regulated DC supply will get because of this regulation circuit. So there are two characteristics, that is the line regulation and load regulation. In load regulation, what happens? There is a difference between, yes, if the change in output, regulated output voltage, when current flow from minimum value to its maximum value. Minimum value is VNL and maximum value is the VFL. And line regulation is what? Line regulation is nothing but the change in current within the range of 230 volt of plus minus 10%. So it may be 270 volt to 253 volt. And percentage of this line regulation is what? Line regulation is also called as source regulation, that is SR, which is equal to SR divided by V normal into 100. So V norm is equal to nominal voltage applied to the circuit is called as the V normal and SR is the source regulator. Okay. So this is two regulations, and load regulation and line regulation should be small for good power supply. For good power supply. Okay. For good power supply, there is a what? Load regulation and line regulation should be what? It should be small. So this is two characteristics. Next we are going to see another point is ripple rejection. What is this? Ripple rejection means what? RR is what? Ripple rejection. What happens in ripple rejection? When there is a change in output voltage, output regulated voltage will get in the load and line regulation. So what happens? There is a change in voltage and it reduces the current and that voltage will back to the input voltage. Yes, that comes again or back to the input voltage, and it is indicated by 1 plus VB is 1 plus beta of V is equal to, it's a feedback factor, and feedback is what? It will go back to the input voltage. That's called as a ripple rejection. Rejection means what? Selection and rejection are these two words. It's the opposite words of the selection, or it will go back to its the source voltage. It's called as the ripple rejection. So in ripple rejection, what happens when circuit flows from, when current or voltage flows from source to destination, its voltage will back to its input voltage. It's called as the ripple rejection. Okay. So next is output impedance. Output impedance. What is impedance? It is inverse of, yes, resistance. Resistance is what? Which opposes the flow of current. Impedance is what? It is the, yes, when output is, supply is given to the output of the, it is opposite of this resistance, is called as the impedance. We will see this point in the next lecture. All of you understand up to this characteristics of the, what? Characteristics of voltage or power supply. Okay. We have seen what the, yes, first point is the block diagram of the power supply. Second is what? It's in this block diagram what we have seen. First block is transformer, second is rectifier. Again we have seen the filter circuit, and we have seen the what? First circuit was what? Which circuit is given first is the transformer, indirect transformer. 3 types of transformer we have seen, and in the second type we have seen the rectifier. 3 types of rectifier we have seen, that is the half wave rectifier, full wave rectifier, and bridge rectifier. Okay. Transformer also are of 3 types. Yes, step up transformer, step down transformer, and mutual transformer. Okay. And next circuit was what? Filter circuit, and that filter is of also 4 types of filter we have seen. First type is capacitor filter, second is inductor filter, and this inductor is also called as the choke filter. Third is the LC filter, and fourth is the RC filter. LC means inductor capacitor filter, and RC is what? Resistor capacitor filter. And last we have seen is what? Regulator. So we have not seen detail what is regulator. First only we have seen the why there is a need of regulator and what is regulator. So what is regulator? It is nothing but to maintain a constant DC voltage at the output, or to maintain a constant and regulated supply at the output is called as the regulation or regulator. Okay. So there are characteristics of regulator or characteristics of power supply. There are 2 characteristics, that is the load regulation and line regulation. Load regulation and line regulation. 2 types we have seen. In the load regulation, what happens? If there is a change in voltage, if there is a change in output voltage, or if there is a change in output regulated voltage, then current will flow from its minimum value to maximum value. It's called as the load current. In the load current, what happens? Current flow from its minimum value to maximum value is called as the load current. In line regulation, what happens? There is a change in current. No doubt there is a change in current, but that change in current should have the limitations, or it have the limit, that is the 230 volt plus minus 10%. Okay, this is the line regulation. All of you understand this? It is a very simple chapter. You concentrate only the points. You try to understand why there is a need of transformer why there is a need of rectifier, why there is a need of filter, why there is a need of regulator. So which circuit will come first, which circuit will come later on. So you have to just understand all these things. These are very simple things, very clear things. Very clear. I want to tell you that why there is a need of rectifier. In day-to-day life, we use this AC to DC converter, isn't it? If your mobile, I have given the example of the mobile charger. If your 230 volt is directly applied to your mobile, then your mobile will be burst. It will be short because it not required so much supply, it required the DC supply. Therefore, there is a need of rectifier from converging from AC to DC, alternating current to direct current, from large voltage or current to small voltage and current. That is AC to DC we have to need. Therefore, that circuit coming into existence is which circuit? Rectifier circuit is coming to existence. But that rectifier is not give the pure DC. That example I have given you. If you want to play the song, then sometimes some song have the distortion and it's not clear. At that time, what is the problem? That is the fluctuation problem, or the AC is there and it's a ripple problem. That the ripple is given in the DC. Ripple is mixed with the DC signal, means AC is mixed with the DC signal. If the signal is pure DC, that song is very clear. I have given this example in which? In the filter circuit. If you are getting DC node out in the rectifier, but that DC is not pure, for that to purify it or to removing the AC, we require the which circuit? The filter circuit. In filter, what happened? We are getting it at the output is the DC supply, pure DC supply, no fluctuations, no nothing is there. But that DC supply is not continuous or not regulated. Sometimes getting, sometimes not getting, sometimes getting, sometimes it is absent. So it is not regulated or it is not constant. Therefore, we need the circuit. Last circuit is what? Regulation circuit. Okay. So we will see in detail that circuit, that is a linear voltage regulator, its characteristics. All these things we have to see one by one. First, just today I want to introduce you the regulation. What is regulation? Why there is a need of regulation? What is the power supply characteristics of this regulation? Two characteristics: load regulation and time regulation. Okay friends, okay students, all of you understand these points? Thank you.